In this lesson, we're going to look at one of the key properties of probability, and we're also going to understand some of the key words from the topic as well. Before doing these examples, we're going to build up to this, so I'm going to change slides first, and we'll get to this towards the end of the video. If you want to read these questions quickly, pause the video and read them now. Let's start with a couple of simple examples. In the first one, we are told an unfair coin has a probability of 1/3 of landing heads up when flipped. We're being asked, what is the probability that it lands tails up when flipped? The key thing you need to know about probability is this. If you are doing an experiment, such as flipping a coin, then the probabilities of all the possible outcomes need to add up to 1. In this case, there are 2 possible outcomes when flipping the coin, heads and tails. The probabilities of those 2 outcomes needs to add up to 1. This probability is 1/3, so what do we need to add on to that to make it a 1? The answer is 2/3, which you could work out by doing 1 minus 1/3 to get 2/3. So the probability of tails is 2/3. If you're wondering how we can have probabilities that are not a half and a half for heads and tails, you probably missed this word here. The coin is unfair. That means the probabilities of heads and tails aren't equal. Let's move on to the second example. This table shows the probability of rolling certain numbers on a biased die. We're being asked, what is the probability of rolling a 6 on this die? The first thing to notice is that the die is biased. That means the probability of each outcome isn't necessarily 1/6. We can see that in the table. The probabilities are not all the same. Remember that key fact I mentioned earlier? The probabilities of all possible outcomes need to add up to 1. There are 6 possible outcomes on a die. You could roll a 1, 2, 3, 4, 5, or 6. That means all of these probabilities need to add up to 1. The probabilities we've got in the table add up to 0.75 if you work that out. So the missing probability is going to be 1 minus 0.75. And that gives you 0.25. So that's the missing probability in the table. If you've never seen it before, the notation I'm using is simply a capital P for probability, and in brackets, I'm listing the outcome. So the probability of getting a 6, in this case, was 0.25. In the earlier example, capital P with brackets tails is simply me saying the probability of the coin landing tails up. And we work that out to be 2/3. Now we come on to some key words in probability that a lot of students find quite tricky, so you really need to concentrate at this point. Before we worry about what exhaustive and mutually exclusive means, we just need to remind ourselves about what event means in probability. An event is simply a collection of outcomes. Let's skip and have a quick look at some events that I've got on this page. So we're considering rolling a fair die later on, and a possible event would be getting an odd number. Another possible event would be getting an even number. So, what's the difference between an outcome and an event? Well, when you roll a fair die, you've got 6 possible outcomes. And remember, an event is just a collection of outcomes. It could be 2 outcomes, it could be 3 outcomes, it could be more outcomes, it could even be 1 outcome or 0 outcomes. Just any collection of outcomes. Let's illustrate that by looking at event A. Event A is getting an odd number. That's either a 1, a 3, or a 5. So event A is made up of 3 possible outcomes. Event B is getting an even number. That is a 2, 4, or a 6. So event B is an event made up of 3 possible outcomes as well. I've shown this in this table. This is going to help us understand the meaning of exhaustive and the meaning of mutually exclusive. Exhaustive events cover all possible outcomes. Mutually exclusive events can't happen together That means they don't have any overlapping outcomes. And we'll illustrate that in the context of all of these pairs of events here. What we're being asked to do is to look at the pairs of events and decide whether they are exhaustive and or mutually exclusive in the context of rolling a fair die. First of all then, events A and B, are they exhaustive? Do they cover all possible outcomes? Well, there are 6 possible outcomes when you roll a die, and all of them are covered by these 2 events put together. You could get a 1, a 2, a 3, a 4, a 5, or a 6. So those 2 events together are exhaustive. Be really careful here. A on its own is not exhaustive. It doesn't cover all 6 outcomes. B on its own is not exhaustive. But together, those are exhaustive events. They cover all possible outcomes. So we can write A and B are exhaustive. We also need to decide whether they are mutually exclusive. Now, you can't have an event on its own that is mutually exclusive. You have to be considering 2 or more events to decide whether they are mutually exclusive. Mutually exclusive events can't happen together. They don't have any overlapping outcomes. Looking at this table, you can see that they are mutually exclusive. None of the outcomes overlap. That just means they can't happen together. It's not possible to roll the die and get an odd number and an even number at the same time. So we can say A and B are also mutually exclusive. Pause the video and have a go at the remaining 3 pairs of events. Decide whether they are exhaustive, or mutually exclusive, or both, or neither. Hopefully you've had a go at these questions. Let's go through them. Event C is getting a number less than 5. That means anything up to 4 on a die. So event C covers these outcomes, 1, 2, 3, and 4. Event D is getting a number greater than 2. So that means getting a 3, 4, 5, or 6 on a die. Are they exhaustive? Yes, they are. These 2 events cover all 6 possible outcomes. You can get a 1, a 2, a 3, a 4, a 5, or a 6. So we can write C and D are exhaustive. Now we have to decide whether they are mutually exclusive or not. We can see from the table that they have some outcomes that overlap. That means you can have those 2 events happening at the same time. For example, if you rolled a 3, you've got a number less than 5 and it's greater than 2. So those events can happen together, which means they are not mutually exclusive, because mutually exclusive means they can't happen together. So C and D are not mutually exclusive. Let's move on to events E and F. Event E is getting a prime number, so that is a 2, 3, or 5. Event F is just getting a 4. Are these events exhaustive? Do they cover all possible outcomes? No, they don't. You can't get a 1 or a 6 from these events. So those 2 events put together do not cover all the possible outcomes. Therefore, they are not exhaustive. Are they mutually exclusive? Yes, they are. Event E and event F can't happen at the same time because they don't have overlapping options. You can't get a prime number and a 4 at the same time. Therefore, they are mutually exclusive. Finally, let's look at events G and H. Event G is getting a square number on a die that is getting a 1 or a 4. That's 1 squared and 2 squared. Event H is getting a multiple of 2, so something in the 2 times table. That's a 2, a 4, or a 6. Are these events exhaustive? No, they're not. They don't cover all possible outcomes. You can't get a 3 or a 5. Therefore, G and H are not exhaustive. And we still have to decide whether they are mutually exclusive or not. You can see here that we have an overlapping outcome. If you get a 4, you're getting a square number and a multiple of 2 at the same time, but mutually exclusive events can't happen together. That means G and H are not mutually exclusive. Those are two new definitions for this lesson. We're going to put them together to come up with a fact that builds on what we said about the probabilities of all possible outcomes adding up to 1. Here's the key fact. If you've got some events and those events are exhaustive and they're mutually exclusive, then the probabilities of those events add up to 1. This basically means that those events, they have collections of outcomes so that none of those outcomes overlap, but they do cover all the possibilities. So it fits in with what you already know. Question 1. On the Walton to Oxton route, the probability that the train arrives at least 15 minutes late is 0.02. Do you have enough information to work out the probability that the train is on time? A train arriving early counts as on time. In this question, the only information we have is the probability that the train is at least 15 minutes late. If we work out 1 minus 0.02, we will get 0.98. But that just gives us the probability that the train is not at least 15 minutes late. So in other words, the train is less than 15 minutes late. That is not the same as the probability of the train being on time. Being less than 15 minutes late could still mean that the train is a bit late. The answer to this question then is no. In question 2, we have more information now. We're told that the probability that the train arrives on time is 0.71. We need to find the probability that the train is late. Now, being on time and being late are mutually exclusive events. They can't both happen together. A train can't be both late and on time. They are also exhaustive. They cover all possibilities. The train is either on time, which remember we said includes being early, or it's late. So because these events, being on time and being late, are mutually exclusive and exhaustive, the probabilities need to add up to 1. So to find the probability that the train is late, we simply need to work out 1 minus 0.71. The probability that the train is late is 1 minus 0.71, and that equals 0.29. In question 3, we need to find the probability that the train is late, but by less than 15 minutes. That is not the same as the probability we've just worked out. 0.29 is the probability that the train is late by any amount of time, including being less than 15 minutes late, as well as being more than 15 minutes late. What we can do is come up with 3 events that cover all the possible outcomes without overlapping. Here are 3 events. The train could be on time, and remember that includes being early. The train could be late, but by less than 15 minutes. Or the train could be late by at least 15 minutes. These outcomes don't overlap. The train can't be on time and late. It can't be less than 15 minutes late and at least 15 minutes late together. So these are mutually exclusive events, and they're also exhaustive. They cover all the possible outcomes for the train. We know 2 of the probabilities to put into this table already. The probability that the train is on time, we know from question 2, that's 0.71. From question 1, we know the probability that the train arrives at least 15 minutes late is 0.02. From everything we've done in this lesson, we should know now that these probabilities need to add up to 1. So these 2 add up to 0.73, which means you can work out the missing probability by doing 1 minus 0.73, and that equals 0.27. Some of you may have spotted that you could work out that answer by doing 0.29 take away 0.02. For those that didn't spot it, I'll leave you to yourselves to work out why that makes sense.